This is something called a rove or staphyliniid beetle, and it's about to show you what might rightly be considered nature's most complicated pair of folding wings. They're usually kept folded up to a fraction of their size underneath the small protective forewings or elytra. But when the beetle's ready to fly, they pop them out, flap them open, and take to the sky. Here's a second look at how they're deployed. When they initially come out, in this footage you can see at least 5 different points at which the wings are folded over on themselves. The only other insect that rivals what these rove beetles are doing are these, earwigs. This is a shore earwig I filmed several years ago, and as it shakes out its enormous wings, you can see how they employ a couple of large flat folds mixed with a series of fan or accordion-like folds. Interestingly, both of these insects can live and be found in similar environments, scurrying through the leaf litter and squeezing under rocks and logs where a big exposed pair of wings would only get in the way. So in dealing with that, they both come to employ extremely compactable and expandable wings. Seeing an insect unfold its wings and use them to fly is really cool, and getting a rove beetle to do it on camera has been a goal of mine for a long time. But with the rove beetle and the earwig, what's even more impressive to see is how they fold up their wings and store them away. And luckily, now I've got footage of both of them doing just that. I only got this footage by capturing and filming these insects immediately after they flew to a black light at night. Both the earwig and the rove beetle were species I caught in central and southern Florida using a light trap setup like the one you see here. So here's what that wing folding looks like for a rove beetle. They use their abdomen to push the wings to the side to perform the first few folds. The wings fold together as a single unit but asymmetrically, each in a different orientation than the other. The second push of the abdomen is from behind and starts to cram the wings underneath the elytra. The third push is swinging the abdomen back to the side and folding the wings so that the tips point sideways relative to the body. The fourth and fifth push that this one does complete the last few folds that finish up putting the wings underneath the elytra and out of harm's way. Now compare that to what the earwig does. This segment isn't in reverse. This one is actually able to fold away its wings without touching them. Now, while earwig wings are bigger and have more folds than rove beetles, you can see how these wings fold up independent of each other and symmetrically. They also don't completely soar away underneath the elytra. With the rove beetles, another impressive aspect is that their asymmetry in folding is not in the same direction every time. An individual beetle can fold its wings up by starting to push on them from either side, because each wing has 2 sets of folding patterns built into it. In the 2 slow motion folding segments you've seen here, it only took the beetles 1.2 and 1.4 seconds to perform all these folds and store away their wings. I should also point out that rove beetles are one of our most diverse groups of animals, with over 60,000 different species. Within that group, they've evolved some pretty interesting ways of life, too. For instance, this is also a rove beetle. This one, in the genus Xenodusa, lives parasitically inside carpenter ant nests. They get the ants to treat them like regular nestmates, even convincing them to regurgitate their food and feed them directly mouth to mouth. Another extraordinary rove beetle that I filmed for this channel is this one, in the genus Stenis, which are famous for their harpoon-like mouth parts. They use them to hunt down and capture prey species like springtails that, in other situations, would have no problem escaping from a predator by using a fast escape jump. With both of these beetles, you can get the idea that they're rove beetles because of their exposed and flexible abdomens and the short protective elytra covering up where the folded, flight-powering hind wings would be. So, rove beetles are way more interesting than just having complex wings, but I think their wings do stand out even when compared to other insects. Thanks for watching.